So we have talked about a couple of different forms of quadratic equations. We have the standard form, ax squared plus bx plus c. And we're going to be working with this one to find the vertex of the parabola today. We've talked also about the factored form. Where we have something like y equals 2x minus 3 and x plus 4 as two linear equations, 2x minus 3 and x plus 4 that are multiplied together. We will talk in the future about using that to find x-intercepts. Yes, x-intercepts, not y-intercepts. There is a third form, ax minus h squared plus k, known as the vertex form. Okay. This is very nice because it's very easy to get the vertex. For a parabola, the vertex is this point here at the bottom. For an upward opening parabola, or if I put a downward opening one on here, it's going to be at the top. So the vertex here is either the maximum point on the parabola, if it's a downward opening one, or the minimum point on the upward opening one. Also through the vertex is what we call the axis of symmetry. And my parabola is symmetric about both sides of the vertex. So in vertex form, notice again, this is the opposite sign. My V is just HK. Very simple. My axis of symmetry, I'm going to call that AOS, is just X equals H. So let me give you an example with these. Here is a parabola in vertex form. My vertex is at H, right here, 3, 7. The default was a minus, so it's 3, 7. Axis of symmetry, vertical lines are X equals 3. And again, I'm pulling the X coordinate. Here's another one. Vertex. Here I've got a +2. That means I'm going the opposite way, so it's -2. +2 being the same as minus a -2. And then -1. Axis of symmetry. X equals -2. Really nice and simple in vertex form. In standard form, my x coordinate of my vertex is given by -b over 2a. My standard form being ax squared plus bx plus c. So in this case, x equals b being -4. I have to take the sign with it. B is the -4. So that means -b is -4 over 2 times a. A here is 2. 2 negatives make a positive. 4 over, 2 times 2 is 4, not 2. Or 1. My x coordinate is 1. In order to get the y coordinate, I'm simply going to plug my x value, 1, into my equation and calculate. 1 squared is 1, times 2 is 2, minus 4 is -2, plus 7 is 5. My vertex is 1, 5. My axis of symmetry is, oops, it's not a coordinate, it's an x equals. X equals 1. Let's do one more example like this. So x, negative b over 2a. Negative 5 over 2 times 1/2. That equals positive 5 over 1, so 5. So again, my x coordinate of my vertex is 5. My axis of symmetry, I don't even need the y coordinate for this, is x equals 5. Again, to get the y coordinate, I plug in. So 5 squared is 25, times 1/2 is 12.5, minus 25 plus 3. That's negative 12.5 plus 3 is negative 9.5. And this is my vertex. I can throw that on the graph. So I graph my vertex. And all I really need to show at this point is that my parabola is opening up because this a value here is positive. If it opens up, if a is positive, it opens up. If a is negative, that's a downward opening parabola. I know that this has a minimum value. I can use this to find the minimum by simply finding the vertex. The minimum is the y coordinate of the vertex. If it were a downward, the y coordinate of the vertex would be a maximum. For a downward opening parabola, again, the y coordinate of the vertex is a max. Okay, and I always give the y coordinate when I'm talking about mins or maxes. And there is today's lesson.